Hello everyone, welcome back to my channel. My name is Sanket, and today this is the day 2 of uh, Linux complete course, and today we are going to learn file system in Linux operating system, and we are going to learn this particular concept, file system concept, with the practical example. And the prerequisites for this particular tutorial is to watch our previous video where we have created a Linux VM using Vagrant, and you also need to watch a day one video of this particular course, that is Introduction to Linux. So without further delay, let's get started with file system. So what is file system? So file system is nothing but a structured collection of files and directories on disk drive or partition. So in Windows operating system, we have local drive C, local drive D. So those are partitions available on Windows operating system. Similarly, in Linux operating system, we have uh, file systems or partitions available. So we have like different partitions available in Linux operating system, like root slash tmp slash var slash home, and each of these partition serves some purpose. Like slash home directory is used to create home directory for all the users, slash root is used for root user, slash root is the home directory of root user, then slash tmp is used to create temporary files and folders. So these are the some common like file systems which are available in Linux operating system. And Linux, in Windows, you might have seen that the file systems that are being used in Windows are NTFS, FAT32, etc. So these are the common file systems that are being used in Windows operating system. Similarly, in Linux operating system, what we use is ext4, XFS, ZFS. These are the common file systems that are being used in Linux operating system. So this is all about like file system, and all these file system serves different purpose. Like XFS and ext4 are the commonly used file systems in Linux, and if you want to have a shared mount point, in that case you can create a nfs mount, like nfs file system, and that file system can be used across multiple servers. So that will be a distributed file system. Nfs is can be used across multiple nodes, and many VMs or many servers can access that particular NFS file system at the same time. So this is pretty much about file system. Next topic is directory structure. Like in Linux, it follows a hierarchical directory structure. What do I mean by hierarchical? So let me log in to the VM that we have created, and I'll show you what do I mean by hierarchical. So let me split this terminal, and the command to log in to our VM is vagrant sh, and this will log in to our previously created VM. So VM is not up, so let me start the VM. So here you can see VM is powered up, so let me start the VM. So VM is finally up and running now. Let me log into this VM using vagrant sh command. The password is vagrant. So we have successfully logged in to this particular VM, and we'll see what do I mean by hierarchical structure now. So hierarchy in Linux directory structure starts from slash, and slash is nothing but a root in Linux operating system. And whatever files that are being created will be created under slash. So here you can see slash have this many directories created. It has slash bin, slash boot, and slash dev, slash etc. All these directories serve their dedicated purpose. So lib directory stores libraries, bin directory stores binaries. Binaries are nothing but applications. So slash root is the home directory for root user. Home slash home is the directory where all users home directory will be present. Slash etc is used for storing the configurations of applications. Slash var is used to store logs. Slash usr is used to store binaries. Slash run is used by RAM. So all these directories have their dedicated purpose. And if you want to see the hierarchy under slash directory, so you can use tree command and you need to provide level. So this is the hierarchy that I am trying to explain. So everything is created under slash directory. So this is all about directory structure. Everything, so Linux follows directory structure and it does follow hierarchical directory structure. Next thing is file CRUD operations and file copy. So in Linux, if you want to create, read, update, or delete files, we have dedicated commands. So in order to create files, touch is the command through which you will create files. So let me switch to tmp directory, and tmp directory is used for creating temporary files. So let me create a file named abc. So here you can see abc file is created. So touch is the command used to create empty files. Next thing is, if you want to edit that file, vi is the editor that you can use. Linux does provide various editors like vim, then nano, etc. There are various editors that are available, but most professionals go with vim or vi editor. So we'll open that file vi followed by abc name of file, and the file will get opened. So in vi editor, if you want to insert some data into file, you have to press I key on keyboard, and this will open this file in the insert mode. Now you can write whatever you want to add in this particular file. So this is the test file we have created for file CRUD operations. Let me save this file. In order to save the content, you have to press escape key followed by colon and wq. So this will w will save the file and q will quit the file. So if you want to save and quit the file, you have to use wq parameters. If you just want to save the content, you have to use w character. So I'll use wq in order to save and exit from this file. Exclamation mark will forcefully exit this file. So let's suppose you have made some like changes. Let's suppose I have made this random changes, and if I don't want to save these changes, what I can do is I will use colon q and exclamation to exit this file, and it will quit the file without saving these changes. So let me try that, and here you can see those changes are not being saved. This is all about like editing and updating the file. If you want to update file, if you want to add or update this file, what you can do is you can simply open this file, and if you want to add, let's suppose, file and directories, then you can simply add directories right here, and this will update this particular file. So here you can see files and directories can be seen here. Next one is you for update. For reading purpose, you can use cat command. So cat will display the file. Cat command can be used to display the file. Next thing, D stands for delete. So in order to delete file, we have rm command, and if I press rm abc, this will delete the file. If you want to forcefully delete the file, you can use flags along with rm, and if you want to see what all flags are available, you need to use rm -help command in order to see what all flags are available. So here you can see what all flags are provided for rm command. So if you want to forcefully delete the file, -f is the flag. If you want to show the prompt before deleting the file, -i is the flag. If you want to recursively delete the files and directories, so here you can see -r is used to remove the directories and their contents recursively. So using rm command you can also delete the directories. So in order to list the files, ls is the command, and -l is for long listing of files. So long listing of files, ls-l is the command that you can use. ls-l will show me the files that are available in this particular directory. If you want to see in which directory you are currently working on, so pwd is the command which shows present working directory. So pwd will show me current directory. ls-l will show me ls-l will show me the files and directories present in this particular directory. And if I want to create file, I will use touch command. If I want to edit file, I will use vi command. If I want to update file, I will again use vi command. If I want to delete file, I will use rm command followed by name of file. So this will delete the file, and no, nothing is present currently in this particular tmp directory. So this is all about file CRUD operations. Next thing is file copy operation. So let's suppose you have created this file. Let's suppose you have created a shared configuration, and if you want to share this shared configuration, if you want to copy this file to remote servers, how you can do that? So the command, there are various commands, but mostly used commands are scp, which stands for secure copy, and the next command is rsync, so remote sync. These are the two commands that are being used to copy files and directories to remote servers. So what is the syntax to copy files using scp and rsync? So scp followed by some flags. So flags will be there, and you have to provide your source file and destination path. So this is the syntax for scp, and for rsync also follows same syntax. Rsync also follows same syntax. So as a DevOps engineer, what all flags you can use? So scp, generally scp -pr is the flag which is used in the industry or which is used by the professionals, and p stands for preserve, r for recursive. And if you want to, let's suppose, copy /tmp /shared config, you need to provide the destination details right here. So app user @destination server name or ip, destination server name or ip followed by path. So path will be /tmp. If you want to copy it inside tmp, then you can copy, then it is possible. If you use any other directories, then you might get permission denied error because app user might not have access to those directories. So this is the way you can copy a shared config file to a remote server. I don't have any other VMs. Currently I'm using single VM. So maybe in future we will show the practical demonstration for these commands. The next command is rsync. So rsync does follow the same structure, but the flags are a bit different. So parv is used right here. So p stands for preserve, r recursive. We will show you the verbose of the copy operation, and you need to provide the same things right here as well in rsync. So rsync will also take the credentials before copying the file to the remote server. So these are the two commands that are being used. So we will make sure that these commands will get added to our notes which are available in the GitHub repo. So that is it about file create operations and file copy. Next thing is disk management using LVM. So we'll uh, demonstrate these three topics with this particular example. And the requirement for this particular project are as follows. First one is to create file system slash app slash data of 2 GB of size and assign dev group full permissions on this file system. Second, once done, if dev team users can access the file system or not. So we need to create file system app data with 2 GB of size, and we need to assign full permissions to the dev group, and we need to check whether users inside dev group can access this file system or not. So let's start with the practical, and we will understand this disk management using LVM, file permissions and file ownership through practical approach only. So we'll, in order to check the current mount points, df is the command which will show you the list of mount points or file systems available. So file systems can also be called as mount points. Let me enter dev command. So dev-h will show me the list of all file systems that are being available on this particular VM. Now the requirement is to create file system slash app data. So first thing we will do is we will create a directory named slash app slash data. So command to create directory is mkdir. This will create directory. So mkdir followed by name of directory. So directory name provided here is app slash data. So here it is failing with the error. So this command is failing with the error, and the reason is we don't have slash app directory, and that is the reason it is saying no such file or directory. So in such cases, if you want to provide some absolute path and you want to create a directory in this manner, then you have to provide -p flag, which will make sure file or directory will get created with all the parent paths provided here. So slash app slash data. Now this time it has created the now this time this has created now this time it has created the directory. In order to check the directory is created or not, you have to use ls-ld command. So here you can see the directory is created with default permissions like 77755, and the users and groups are root. Okay, so let me explain. Now let me explain the meaning of this particular output. So ls-ld is showing us the details for slash app slash data directory, which is the requirement given in the example. Now various details are being shown in this particular output. It starts with D. So D stands for directory. If there is hyphen here, that means this is the file, normal file. Let me create random file, and let's check the output here. So here you can see the hash hyphen is here. So hyphen is given for normal files. If the output of ls-ld starts with D, then that means this particular thing is the directory. If it starts with hyphen, then it represents this is the file. The next thing right here you can see is the list of characters. So these characters are nothing but the permissions. These characters are nothing but the permissions on this file or directory. So what all permissions? Here you can see some permissions have been given here for this directory. So directory permissions, directory permissions. These are directory permissions and these are file permissions. And these are the default permissions that have been given here. In order to assign permissions or in order to read the permissions, we need to understand what all file permissions are there. So we have three types of permissions in Linux. We have three types of permissions in Linux. First one is read, and it is denoted by, so there are various representations. It is denoted by character R, and in numeric form it is represented as number 4. Second permission is write, and it is represented in character form as W and in numeric form as 2. And third permissions that is available in Linux is execute, which is denoted by X, and it is represented in a numeric form as 1. So numeric form is used when you assign permissions to the files and directories. So here you can see the file permission, the default file permission is RWRR. So in this particular output you can see a user and a group is mentioned. So user permissions are denoted by first three characters. So in this particular output, RW hyphen is first three characters, and these are the user permissions. The next one is R hyphen hyphen. So first place is given for read, second is R for write, and third one is for W. If you don't want to assign any typical permissions, like in for user we haven't assigned execute permissions, so at that place you have to put hyphen, or Linux will put hyphen at that particular place. So user only have read write permissions, and at execute it has placed hyphen. Then group, so group permission given here is read only, and the write and execute place is filled with hyphen, and the remaining three places are given to other users and others permission. So this is also read. So these are the permissions which are assigned in this format. So first place is given to user have their so first three places are given to user, then next three places are given to group, and last one are given to others. So ls-l, so this in this particular case the file permission is 644. 6 because rw, the addition of rw is 6, 4 plus 2 is 6, read write is nothing but 6. If you want to assign full permission, that means 777 is the full permission. If you don't want to give permission, 000. So let's try with some examples. So let me remove all the permissions for all the users group and other users. If I now check ABC, here you can see all the places are filled with hyphen. If I do that for app data directory, Now app data directory is having 755 permissions. Let me give 000 permissions, no permissions on app data directory. If now check, it only shows that this is the directory. First character is the type of file or it denotes. So and all the places are filled with hyphen, which simply denotes that this file doesn't have permission for anyone. If I want to give read only permission to user, then the command would be for read we have to use 4 number. So 400/app/data. This will make sure that only user can able to read this app data directory, or user can able to read this app data directory, or user can able to read this particular file. Let me assign these same permissions to the file. So user can able to read this file. If I want to assign permission to other users, so let me assign full permission to other users. So the command would be 007. So 0 means user have no permissions, group have no permissions, and 7 for other. That means other user will have full permissions on this ABC. ls-ld ABC, and here you can see rwx is assigned to other users. So similar way you can assign the permissions to the files and directories. One more thing to note here is, if you don't have execute permission on directory, then you won't able to go inside that directory. So this is the interview question. If we, let's suppose we have directory named /app/data, and the permissions for this app data is read only. Now as a root user I can able to switch to the directory, but if I try the same thing, now I have switched to vagrant user, and if I try to access this app data using vagrant, then I will get the error. So to switch the directory, we have to use cd command. Cd command is used to switch the directory. So let's suppose I want to switch to /app/data directory. So here I will get an error because we don't have execute permissions, and the owner and the group for this app data is root user only. So let's try. So it says permission denied, and the reason is simple, because we don't have execute permissions for other user on this app data. This is failing. Now let me simply assign execute permission in order to see whether vagrant user can able to go inside this app data or not. So chmod. So in order to assign execute permission on app data, I will use chmod command. So chmod command is used to like assign permissions, and chmod followed by 001. So first thing is, we already have 4 read permissions, so we'll keep read as it is. 0 for group doesn't have any permissions, and last 3 places are used for other user, and other user will have only execute permission. So execute is represented by 1. If it was execute and write, so it would have been 3. Since it is execute only, we have to use 1 number, and we'll provide the path /app/data. So here this app data will now have access to other users as well. So let's try it. So in order to check the current user, the command is who am I to check current user. So if I type who am I, it will show me I am a Vagrant user. And if I try to go inside app data directory, then this time it will go inside this app data directory because other user have execute permission on this directory. And here you can see we are inside app data directory. So this is the interview equation, and you need to smartly handle such type of interview questions. If you don't have execute permissions on this directory, then you will get an permission denied error. So they might ask what error you will get. So permission denied error you will get. So this is pretty much about file permissions. And if I want to change the ownership, so current ownership is root and root. So first, this place is represented for owner or user of this particular directory or file. In app data case, this is root only, and in this file also the owner and the group for this file is root. So if you want to change the owner and the group of that file or directory, the command is chown, and it is used to change ownership of file or directory. So let's change let me create a group, a one user, app user and app group, dev group. So let me create, so we'll create app user and dev group for this particular example, and we will add this app user inside this dev group. The users and group management is the next session. So for now, just follow the commands. So in order to create user, we have user add command, and we will create app user here. In order to create group, the command is group add. So in order to add this app user inside dev group, the command is user mod, which will modify the user settings, and user mod followed by -a-g followed by name of group and name of user. This will add app user to dev group. And to check whether the configuration is done properly or not, you can use id command to check what all configuration is present for this app user. So here you can see user id is 1005, group id is 1006, and app user is present inside this app user group and dev group. For now, we will focus on changing the ownership of file. So since we have app user and dev group, now we need to change the ownership of this app data. So current configuration of this app data says that root is the owner and root is the group of this file. But I want to make sure that app user is the owner and dev should be the group for this particular directory. So to do that, the command is chown -r. R means recursive, and you need to provide the owner and the group for this particular directory. So owner is app user followed by group name. So group name is dev and the directory is app data, and you can check the output now. So the user and group is now changed for this directory. As per requirements only, they want dev team to have full permissions, and only user should access this app data. So app just, so this permission denotes user will have full permissions, group will have full permissions, and zero means other user will don't have any permissions. Let's see, and here you can see required permissions have been assigned. Now next thing is to, this is just a directory, and here you can see we don't have any app data mount point or app data file system. So the next thing that we are going to cover is disk management using LVM. So to create a file system, there are various options available in the uh, Linux operating system. So first one is, you can partition, you can use physical partitioning of disk using a disk or parted. Or next thing is using logical volume management. So in this particular session, in this particular course, we are going to cover LVM, because physical partitioning is not really used. Physical partitioning only used in case of a root file system, which is, or boot file system slash boot file system, which is used to store kernel information and boot information. So for now we will focus on logical volume management, and we will create file systems using LVM. So in logical volumes we have three main uh, concepts. First one is physical volume. Physical volumes are nothing but disks attached to VM. Second important thing in LVM is volume groups. So whatever disks that are being attached to VM can be clubbed, or that can be grouped into volume groups. So clubbing, grouping of disks as per requirement. For example, you will group disks for DB database volume group. You can group disks for app volume group. So VG is the short name for volume groups. PV is the short name for physical volume. So this is the second thing, volume groups. And third important thing is logical volumes, which is denoted as LV. And logical volumes are nothing but the mount points that you generally see. So logical volumes will be used as a mount point for your file system. So these are logical volumes created out of these volume groups. So these are the fundamentals for LVM. Let's focus on these requirements now. So we need to create a file system slash app data of 2 GB, and we need to assign dev group full permissions on this particular file system. So first thing is, we need to add a disk of 2 GB to this particular VM. And so first, let me add 2 GB disk to this particular VM. So we'll go to storage and we will try to add disk right here. So add hard disk, create hard disk, virtual hard disk, next fixed size, and we'll change the size to 2 GB. We have chosen 2 GB. So disk is being created, disk has created. So this is the disk that we are going to use for this particular demonstration. I have added the disk to the VM. Let's see whether the disk is added or not. So lsblk is the command to show list of disks attached to this particular VM. So let me enter lsblk command, and here you can see a newly added disk is present. So STD is the disk that is being added. If you want to see where these disks are being created or stored on the operating system, so the path is /dev, and inside /dev you will see all the devices that are created for your particular server or VM. So these many devices are present, and here you can see various devices that are present for this particular VM. /dev/std is the disk that we have added, and here you can see it is being started with B. So B stands for block device. And if you see the output here, the various types of uh, files are various types of devices are present here. So these are terminal sessions which are starting with C, and further you can check by yourself what all devices that are present inside slash dev. So first thing is to add this. Next, create PV. PV stands for physical volume. PV, VG, volume group, and LV. So we need to create PV, VG, and LV using this disk. Once you create PV, VG, and LV, the next thing comes into picture is formatting your disk. So format disk, format LV basically. So we have XFS and ext4 file system. So you need to format your logical volume using this file system. Fourth thing is entry in slash etc slash fs tab. So this will make sure that your file system will persist and it will get mounted when you reboot your VMs or servers. Fifth thing is create directories, create file system directory, and assign permissions. And last step is use mount-a command to mount file system. So these are the 6 steps we are going to perform. First step we have done. Second step is to create PV, VG, and LV. And the command to create PV, VG, and LV are as follows. To create PV, command is pvcreate, and we need to pass the device path. So that is slash dev slash std. To see whether the PV is created or not, pvs is the command to show the list of PVs that are available. So here you can see slash dev std is added as a PV. Next thing is VG. So in order to create VG, the command is vgcreate followed by VG name. So the VG name we will provide will be dev VG, and we need to pass the PV for this particular volume group. So that is slash dev slash std. In order to see the available VGS is the command. So VGS, inside VGS we can see dev VG is created with one physical volume. LV logical volumes are 0 as of now, and the size of PV is 2 GB. Free size is 2 GB. Next thing is to create LV. So command is lvcreate followed by -n to provide the name of LV. So dev LV followed by the uh, space which is requested. So in this case the space requested is 2 GB. So here we will provide hyphen capital L plus 2G followed by name of VG through which you want to create this LV. So name of VG is dev VG. Here we can see we are getting error. So 511 extents are available and 512 are required. So when we provide space, when we specify the size of LV in this format, we might get this error. To resolve this error, we need to use different flags. So -l is used to provide the size. We'll use different flags right now, and -l will take the input in extents. Caps L will get the input in the form of size. -l will take the input in the form of extents, and I want to use all this space available in VJ. So -l plus 100% free. So this will take all space present inside dev VG to create this LV, and we need to provide VG. So here you can see LV is created now. and using LVS you can see the output of this particular LV. So dev LV is created with size 2 GB. So this is all about uh, creation of PV, VG and LV. So for now we have completed 2 steps. Third step is to format our LV using one of the file systems. So we will use XFS file systems, which is the default file system for most of the operating systems. So command to format file system is mkfs followed by file system name XFS, and we need to provide the absolute path for this LV, that is dev mapper dev vg dev LV, and this will format the disk. So disk RLV is formatted with XFS file system. So we have completed third step as well. The fourth step is to add entry inside etcfs tab. So we will open the etc tab file, and here we will create a entry for slash app data mount point. So slash dev slash mapper dev vg hyphen dev lv is the device, is the absolute path for our LV. The mount point is slash data slash app slash data. The file system is XFS, and we will use the default parameters right here. So for we have so far we have completed 4 steps as well. Fifth step, we have already created a file that required directory, and we have already assigned the permissions. So we will once again check whether the directory is available or not and required permissions are available or not. So here you can see app user and dev group is having full permissions on this directory. Next thing that we are going to do is to perform this last step of this particular operation, that is mount hyphen a. So mount hyphen a will read the configuration inside etcfs tab, and it will mount the file systems which are available inside fs tab. Let's try mount hyphen a, and let's see whether our requested file system is created or not. So here you can see the requested file system is created, and as per the requirement we have completed the first step of this particular requirement. So after mounting the file system, the permissions are changed. So you need to assign the permissions after creating the mount point, and the command to assign full permissions for user and group is 77, and we need to change the owner and group for this particular file system. So chown is the command, and this will assign, this will change the ownership from root to app user and dev group. So we have finished these tasks. The next thing is to perform the final checks. So let me switch to app user, and currently I'm inside app user, and let me try to switch to slash app slash data. Here I'm able to switch to app, I'm able to switch to app directory, and I'll let me create some files: touch config mkdir logs mkdir bin. Let me check those files are created or not. So here you can see the files are created. Now let me exit from the user. So here you can see the files are created inside app data with user app user. Now let me switch to vagrant user and try to create files inside app data. And here you can see a vagrant user is getting permission denied. so vagrant user is unable to go inside this app directory. So this is the beauty of Linux. This is the beauty of this file permissions and file ownership. And with this, we have completed the session on file system. If you have any doubts, post it in the comment sections. We will be happy to assist you with all the doubts and queries you have. In next session, we will go through user and group management, and we'll see what all commands are available to create users and group, and how we can efficiently manage the groups and users in Linux operating system. Thanks for watching this video. I have tried to cover this session with practical approach, and these are the same requirements that you will get when you start working as a DevOps engineer. So this is it for this particular session. Thank you for watching, and if you like this video, please give it a thumbs up, and if you have any queries, please feel free to post it in the comment section, and please share this channel with your colleagues and friends who want to study DevOps, who want to study Linux. Stay tuned for more such tutorials. Take care and see you soon. Bye.